or just like an intro, because this is our inaugural podcast, right?
The biggest inauguration
you're the first
ever.
And so at that point, I'll say, hey, thanks for coming. So everything, I mean, since he's been filming is relevant. And
The semiotics of creating reality.
So, which is how we encapsulate this, because when I thought about you as a guest, I was like, this is going to be easy, right? Because you're one of the smartest people that I know, if not the smartest person I know.
I don't know what that says. I think I'm not sure.
It's scary. Like, I would never want anyone to say it about me. Not that I have to worry about that, but.
What does it say about the other people you know? That's what I want to know.
Well, you know a lot of the other people that I know. But, so I was like, and it's not enough to just say that, right? Because how do you tease that out of, how do you demonstrate to an audience that, oh, this guy is in fact, one of the smartest guys. So forget that, and let's talk about the fact that you're probably, if not one of the smartest guys, you're probably the best guy to tell the average person the story of the earth. And I was like, fuck, that's solid goal, And then I started thinking about some of our previous conversations, and I was like, well, we've established the perfect frame of reference, because I want you to talk about everything from 4.6 billion years ago up until, what is it? What do we got? 6 billion more years?
Yeah, 5 or 6, depending.
So there's your frame of reference.
Right, all of it.
All of it.
All of it. There you go.
Easy.
Well,
because remember, I was encouraging you to write a children's book.
Yep.
That would demonstrate that time frame in some digestible way, right? Because I think everybody needs to understand that basically. That's what we're working with, right?
Well, and look, the immediacy of what's happening right now in the country, in the world, and I tell this to my students. In-person classes for the first time in a year and a half. Everybody's there and they're jazzed to be in a room with other people, right? To work off of those visual, auditory, smell cues that humans rely on to feel human. And what we're dealing with right now is the fact that for one reason or another, a new viral form has emerged and spread into the human population. And the recognition at one level or another, whether it's conscious or unconscious, that we are food. Right? There's enough of us around, and we're in enough contact with each other around the planet, that there are forms of life that are like, okay, new food source, widespread, active, carries us, right? We represent an enormous resource for some of these quote unquote lower forms of life.
And this is a huge irony for us, right?
Right? Because we have always considered ourselves to be at the top of the food chain, right? And for a significant chunk of time, any animal, plant, rock that was in our way or presented something useful to us, we used it. We took it. We crushed it up. We cooked the good stuff out of it. We cultivated it. We cut it down. Right? And that included other groups of people as well. And so for us, as human beings, being able to extract materials from the world around us and turn those materials into things we could use for tools or shelter or clothing or food is sort of, that was baseline. That was what we did. And whether it's a conscious realization or not, part of the fear of this virus and the fear of any contagious disease over the last several thousand years, whether it was Black Plague or smallpox, is the fear of being toppled from the top of that pyramid. We are not the be-all and end-all. There's creatures or organisms or little molecules out there that can invade us without us knowing it, and turn us into food. Right? And we're now the raw material that's getting extracted from the environment by something else. And when you talk about the history of the planet, and we were talking about this a little bit earlier, when it comes to the physical or inorganic chemistry, the way that things work in the purely physical, non-organic, non-biological world, fairly straightforward, right? You've got these many electrons and this much energy required to make this kind of a bond, or you've got this much mechanical energy that's going to generate that much heat. You can calculate it, you can get, within error. Radioactive decay, we know that these many radioactive decays are going to happen in a certain period of time, right? So you go back to the early solar system, and we actually have samples of stuff from the early solar system. We've got meteorites, rocks that have dropped onto the planet. We now got samples from outer space. We can figure out how old they are. And we can look at their chemistry and their texture, and we can understand something about how the solar system formed. And then we can use our telescopes and go look at other solar systems and query their chemistry and look at their shape and learn something about that basic process of how a star system forms. We've got some pretty good ideas, right? We understand a lot. We don't understand everything. We're always learning new stuff. But the basic idea is there. But when we start looking at the planet itself, our planet, which is so far pretty freaking unique, because it has life on it, and it has all three phases of water, solid, liquid, and gas phase water at the surface at the same time, right? And that combination of organic molecules, which are actually pretty common in the universe, right? You can find them in comets, plus liquid water in constant volume, constant presence at the surface, plus a certain amount of energy from the sun or energy from the internal heat of the planet. You start, those organic molecules that stuff is hard, right? Organic chemistry and biochemistry is hard. But what we see when we look at the Earth and we start comparing it to other things that we can study, like the moon or Mars, is that the number of minerals, right? Minerals make up rocks. We query those minerals to see how they formed, what they're made of, what temperature and pressure they require. We look at them and we can tell a physical story about the development of the planet, okay, and the structure of the planet. But somewhere, 3.5 billion years or so ago, there began to be these molecules that could replicate themselves and extract energy from their environment to do so. If we go and we do a census of the number of minerals on Earth, the number is about 4,500 different unique mineral structures, right? If you go to the moon and look at the minerals on the moon, there's like 50. Mars, maybe 100. Now that number's going to grow because we're going to find more stuff. But the fact that it's like 2 or 3 orders of magnitude more minerals on this planet than any other planet or moon that we've looked at is an indication of something very strange. And what's very strange? Liquid water, free oxygen, and life. Right? The life process has enabled a chemical environment that produces more variations on the physical organization of atoms into crystalline structures. So there's this weird feedback between life process and the physical baseline process that happens everywhere in the universe that creates more variability. That process is playing out in front of our faces right now. And it's really frightening. Here's this organism. Viruses, can you even call them organisms? Right? Are they alive? Well, they replicate themselves, and they do so by extracting energy and using resources from their environment. So, okay, fine, it's a life form. It emerges from somewhere. Now, there's a lot of argument. Did it come from a lab? Did it come from the wild? Was it engineered? And I honestly think that argument is going to be settled very definitively in favor of natural origins. Okay? We don't yet have the ability to engineer molecules at that level. And the traces that we leave behind when we do that kind of engineering are blatantly obvious to anybody who knows what they're doing. And none of those traces are visible in this particular sequence.
Explain that a little bit more.
Oh, well, you've got
people are going to want to,
Okay, so keep in mind, I'm not a virologist. I'm not a highly trained biologist. I'm a scientist. I can read the papers. I can follow the reference trail, and I can figure out what they're talking about. But I can't do it in the lab. And the high-level statistical, fine detail scientific evaluation is not in my wheelhouse. Okay? But whether we're talking about CRISPR, or we're talking about some kind of yeast-based where they basically they'll take a yeast or some other bacteria, and they will put the viral sequence into that environment, and the virus will infect the bacteria or the yeast or the whatever, and that will then divide and grow, and you'll begin to get sequential populations. And then from those sequential populations, they will try to choose the one that does what they want it to do, right? So they sort of accelerate evolution in an enclosed environment, and then pick and choose which version of that sequence is the interesting, right? This is one of the ways that bioengineering is done. And there's a whole bunch of different substrates that they can use to do this, and a whole bunch of different techniques that are used to do this, and all of them leave behind a very clear signature, right? If you use CRISPR, it's because you're using a particular sequence from a bacteria to go in and cut a DNA strand at a very particular place, right? There's a certain sequence of nucleotides in a certain order that this particular strand or snippet is good at cutting. And we can see in the genetic sequence that comes out of that, we can see where it's been done, right? It's like if you look at a piece of wood and you can tell whether it was cut with a handsaw or a circular saw or a bandsaw or a water jet, right? You can see from the marks on the piece of wood what was used to cut it, right? It's the same idea. None of those signatures are visible in the stuff that's causing this contagion, right? Now, maybe somebody in a lab somewhere has figured out something different, and somebody was fucking around and found out, right? It's possible. But the reality is that there are coronaviruses. It's an enormous family of viruses. They've been in the human population in various forms for many, many years. We've known about them since the 1950s. Probably in the human population for centuries, right? Any number of instances of epidemics or localized, sort of nation or regional pandemics that have the same signatures of what we're experiencing now. And these coronaviruses live in cat populations, dog populations, pangolins, armadillos, civet cats, mink, you name it. Because when this emerged, one of the things that happened is enormous numbers of teams of biology types started doing surveys in South Asia, East Asia, and Southeast Asia, because that's one of the places where it seems like this is most prevalent. Interestingly, it's also one of the places where it has not burned as hot, possibly because of prior exposure. Right? One of the things that's been going on is that there are apparently some regional differences in population-wide impact of this virus. You know? And one of the possibilities is that's because these particular populations of people have been living in regions where this virus is more prevalent to begin with. They already have some inherited or developed immunity to some level or another. These are things we don't know yet. They're suspicions, right? We're trying to test. But all it takes is, you cut down a little bit of jungle and you disturb a mouse population that comes in contact with a bat population that comes in contact with a cat population that's living on the fringes of a pig farm. And a little bit of crossover, and then a pig gets it, and then the people who handle the pigs touch the pig's blood, take the pig to market, butcher the pig, right? And there's a potential for a jump. And we've been following these jumps in any number of diseases. Lyme disease, anaplasmosis, alpha-gal, Zika, equine encephalitis. The number of new diseases that has been entering the human population has been increasing measurably over the last 5 decades. Okay? The slope of that increase follows the exact same curve, shifted slightly in time, as the slope that describes deforestation, the slope that defines or describes the expansion of human development into the wild, the slope that defines the change in temperature of the planet, and the slope that defines the increase of carbon dioxide in the atmosphere, right? Because we live fundamentally in a large but finite and enclosed biochemical, biophysical environment. And the things that happen in one part of that system are going to change the way material and energy is processed through the biosphere and enable certain organisms to come in contact with food sources. And that process has played out time and time and time again over the last 3.5 billion years. We can see it in the fossil record. We can see it in the chemical record. Right? We don't necessarily have to query just the fossils, which are shapes that are preserved in rock. But we can actually, at this point, go in and extract particular signatures from layers of rock and look at the change in the biosphere environment, the change in the chemical environment within which the physical, chemical, and biological are all interacting. Okay? And it's a finite system. And that's the key, right? Because in an infinite system with infinite room, the consequences of an action basically dissipate to nothing, okay? If you go out into space and you send a light flash in a random direction, it's just going to continue on straight through the universe until the light energy is so dissipated you don't even know there's a signal. But if you take that same light source and go into a room that's got mirrors on all 4 walls and the floor and the ceiling, and you shine that light beam is going to bounce back and forth and not dissipate nearly as much. And it's going to have an impact. It's going to bounce off the mirrors. And if your mirrors are sensitive enough, you can tell when the photon bounces off it. Right? So you've got an echo chamber. This is like a giant echo chamber, our planet. And the things that happen in one place reverberate through those systems. And the more rapidly and extensively those systems are interconnected, the bigger that signal is. As our population grows, we impinge upon other biological systems. And those biological systems respond. A whole lot of them adapt or disappear, right? That's what extinction is, right? And others take advantage. They're like, oh, cool, right? Hook into this, reproduce 1 trillion times, spread from this source to the 50 sources of potential food that this one has come in contact with, right? And if you look at maps of the spread of the coronavirus over time, you can see how it radiates outward. Just like if you drop a hot coal onto a field of dry grass, you can see the fire spread out in a circle, right? So you've got a hot spot in one place, and as people travel and move and interact outward from that central point, you get this sort of expanding wave front moves outward from that central point. That interactivity is what has built us and preserves and sort of maintains our economic wealth, right? Movement is the thing. You know, travel, transport, shipping, commerce, all involves people going places. Yeah? And our experience trying to be online and do everything remote, frankly, everybody hates it. It doesn't work well. It causes disruptions in the economic infrastructure. We can see this, right? And that's because movement and interaction, the exchange of information, the exchange of goods and services, the exchange of material, is done on a basis of movement and contact. And now what we're not interfering with, but now what we're experiencing is what happens when something adapts to that behavior. And the thing that we need to realize at a species level, right? And sort of intellectualize and integrate into our model of the world that we use is if we're going to do that stuff, we have to understand both the potential benefits, which we can see around us, right? And the consequences and the potential risks, right? If we're going to have rapid transport across the world for thousands and thousands and thousands of people an hour, there are consequences to that kind of behavior. And some of those consequences, you know, we can talk about cultural diffusion. We can talk about, you know, sort of the disruption of lifeways of unique and individual peoples, right? That's a big deal. There's some cultural stuff in the world that's really, really cool that's not going to survive that amount of interactivity. And at a human level, we want to try to preserve that. That's why we have museums, right? That's why when people go through old record collections, they're like, oh man, check this out. But at a larger level, that kind of interactivity, that growth of population and growth of interactivity is a very, very large and rich source of food and energy for a whole bunch of critters, right? When we go back and we look at that geological record, 3.5, 4 billion years, right? What we see is how different organisms have both leveraged their environment to gain access to energy, nutrients, growth space, and as a result, changed that environment. The Earth's original atmosphere was 20% carbon dioxide and 0% oxygen. And over the course of a couple of billion years, from about 4.5 to about 2.5 billion years old, organisms that ate carbon dioxide and produced oxygen essentially changed the entire composition of the atmosphere from 20% CO2 to a couple hundred parts per million, 0.001, 0.002% CO2. And from 0% free oxygen to 20% free oxygen in the present. And the consequences of that are enormous. Changed everything about the atmosphere, the oceans, and the upper kilometer of rock and sediment and soil. Right? And we can trace that through. Here's another example of that. Way back, 400 million years ago, there were no plants on land. All of the photosynthesis was being done by algae, various single-celled organisms, maybe some plankton, maybe some organisms that looked a little bit like corals in the ocean. And maybe on land there was some, I don't know, algal mats or, you know, some sort of moss, fungus, scum living on the rocks somewhere, right? But no roots, no stems, no leaves. Which meant that there was an enormous area that was unoccupied, and through competition in the sort of established zone, like here's where it's good to be. You know, you got to live in the upper, you know, foot of the ocean, and you have to float so that you can get sunlight. And then everybody's doing it. And you're like, Jesus, there's no freaking room here. Somebody's like, hey, wait a minute, there's all this land. The development of land plants with roots and leaves that can grow up and spread out changed the way that all of the rivers on the planet work. If you go back, you can see this in Pennsylvania, some of the outcrops on the highways in Pennsylvania. You go back, prior to the development of land plants, all of the rivers were wide, sandy, shallow, what we call a braided stream. It's the kind of thing that if you go up to where a glacier is melting out, and there's this like huge rush of water, and there's this 2-mile wide quote unquote river. Sometimes it's flowing over on one side, sometimes it's flowing on the other side. There's no river channel, there's no riverbank. There's just this huge flat floodplain outwash thing, and it's all gravel and sand.
A desert lake bed. Sounds like a desert lake bed.
Yeah.
The water just kind of moves in.
The water moves in, and it's this flat sheet of water, and sometimes it's fast over here, sometimes it's fast over there.
Right.
Right? So that leaves behind a very unique geological layer. We can see it, we can measure it, we can look at the shapes, we can see where the current was flowing. Land plants develop, and all of a sudden now we have rivers. And there's a river channel that's deep and a river bank that's steep. And the difference is clay. Okay? Because plants, you can see this. If you go out into an area, you can see this up here in upstate New York. You can go to like Tinker's Falls or Pratt's Falls, and you can see where the rock is getting crushed up in a waterfall or a steep stream. That rock comes out onto a floodplain. Trees grow. And they bind those rocks into clumps, and they send their roots out, and they crush, and then they squeeze, and they extract from the rocks chemicals that they need for part of their life system. And they leave behind clay.
Do we see any evidence of this ever happening on Mars at any time in its previous history?
Not yet, no. Right? That's one of the things about Mars soil, is it's not soil. There's no clay, no organic material. Right? Mm-hmm. It's sand, really fine sand, really, really fine sand, and really, really, really fine sand. Gotcha. There's no clay or very little real clay, right? So the activity of plants changes the characteristics of the soil, adds another kind of rock fragment, rock particle, mineral fragment that has very specific characteristics. It's a binder. And so you go from these flat, wide, braided streams to channelized rivers with riverbanks and clay. And the entire surface of the planet changes its texture, its fabric, and its behavior as a result of the evolution of plants with roots. Right? We can see this kind of thing happening over and over and over again. When big biological changes happen through evolution or through some kind of event, there's a period of time in the Permian, right? Permian and the transition to the Triassic, 250 million years ago. And at that transition point is the greatest mass extinction that we know of. Something like 90% of life on the planet died.
And how long ago is this?
250 million years.
Okay.
Right? This happened in conjunction with several things at the same time. There was a massive volcanic eruption in what is now Siberia. A volcanic eruption that covered half of Siberia with lava flows a mile thick. Like, this is big. And it erupted through coal beds and burned all the coal and pumped enormous amounts of CO2 in the atmosphere. And the rain got acid and the oceans got acid. And a new microbe evolved that was a methanogen. It was good at producing lots and lots of methane really fast. The consequences are global warming at an extreme rate to an extreme degree. The oceans got so acid that the limestone deposits that are left from that period of time have been etched. Right? It's like putting hydrochloric acid onto a block of marble.
What was the microbe?
I forget the name of the microbe, but it's. I mean, fundamentally, if you, I could look it up, but if you Google, Permian methanogen, you'll come up because it's pretty hot new research in the geological world. But the point of all this is not to go through a list of all of the things that happen, right? The point of it is to understand from some kind of systemic perspective how these large, interconnected, interrelated feedback loops play off of each other in this finite environment we call the Earth. And to realize that at a fundamental level, despite all of our technological prowess, we are still very much an integral part of that system. Now, this is it's really easy to get off into sort of hippy-dippy Gaia land, right? Oh, we're all part of the world, blah, blah, blah. Which, to a certain degree, is accurate, okay? But it gets too metaphysical. And when you start getting really spiritual and metaphysical about this stuff, it's not accessible. You can't sort of take it apart. You can't look at it. You can't be sort of cut and dried and bold about saying, hey, as a civilization, globally speaking, we need a certain amount of energy, certain numbers of resources, certain numbers of calories. We have to get them from somewhere. But what we're getting them from is not infinite and is not passive. What we do has an impact, and those ripples spread out, and the consequences of those ripples down the road are going to impinge upon our experience. And we do actually have the ability to start to measure and calibrate and calculate to some degree. Okay? Never perfect, right? Anyone who starts talking about the sciences as if they are the be-all, end-all panacea we can know everything, we can control everything is wrong, right? The universe is really big, the world is really big. The interactions are things that we don't fully understand, but you can start.
So where would you, let's talk about a fork. At some point, all this activity is happening, and then there's the emergence of self-awareness, reason, right? And you explained it to me in terms of teleological.
Right.
So talk about that, because I think that is an interesting way of framing the way that we humans think or feel about the earth being in service to our needs.
So here's the thing, is that okay, so to start with, I mean, all of us are born as helpless infants, right? We can't feed ourselves, we can't move around, we can barely see anything. The noises we hear make no sense to us. The noises we make are instinctual, guttural cries for assistance, right? You know, and the processing distance between impulse or feeling and expression is essentially zero, right? I feel good, I giggle. I feel bad, I cry. That's it. Yeah? Reason, logic, self-consciousness, self-awareness, the awareness of the difference between the other and myself, the recognition that this other thing that looks and acts an awful lot like me actually has a completely different perspective and experience that I cannot access or share. Takes years, right? You know, if you have kids and you've watched them develop, you know that by the time they're 5 or 6, they start to get the idea that other people are different from them and don't necessarily know what they're thinking or want. And they learn to begin to query or interrogate or ask or demand things that they want because they know that you don't know it yet, right? When we start out as infants, we are in the absolute and utter control and power of giant creatures with enormous strength and resources. We don't know how that works. We have no idea what they're doing. But we begin very quickly to learn, because a human brain at infancy is at its most powerful. The plasticity and flexibility and sort of growth potential of the human brain of an infant is unbelievably large. Think about this. A human can learn to be fluent in a totally unknown language to associate sounds with objects and actions in 3 years. Can you imagine being fluent in a different language entirely from 0 in 3 years? No, right? So infants, children, are incredibly intelligent, but also incredibly, almost perfectly naive. They're in the utter power of these giant creatures.
Sounds like AI.
Right? Pretty much is. And they quickly learn that certain actions cause certain responses. If I make this kind of noise, then this happens. If I do this kind of thing, then that happens. So if I scream and kick my legs, my diaper's going to get changed. Right? And if I giggle and coo, then I'm going to get some food. Right? If I whine and cry, then somebody's going to pick me up and pat my back. Right? This environment generates what is called teleological thinking. Teleology is the idea that a thing is made for a purpose. Something happens for a specific reason. And in the philosophical world, teleology is a word that's used as an insult, right? But it's not really an insult, because there are things that are true teleologies. We make shoes to protect our feet. We make gloves to protect our hands. We build houses to keep the rain and the sun off of our living space. These are teleological statements that are accurate. This was made for this purpose. And as infants, we have this teleological thinking, right? That these creatures are here to protect or punish, to provide joy or pain, to provide food, right? And that if I do certain things, then other things will happen as a result. That teleological way of looking at the world is fundamental to our early childhood development. We all have it. There have been a number of studies that have been done showing the way that different people respond to teleological statements. Here's an example of a false teleological statement. The sun shines to provide light for plants. Well, no, right? The sun shines because fusion of hydrogen into helium generates a little bit of extra energy that comes out as a photon, okay? And that light goes out in all directions from a star, and some of it hits a planet. And most of the planets that get hit by that light have no plants on them, okay? One of them does, and the plants are like, ooh, energy, I can use it. Nom, 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 nom. Right? So what happens in those studies of people sort of thinking about their world is if we divide people up into groups based on the educational level that has been beaten into them over the past 20 years or so. If we take hard scientists who've spent 25 years in school querying and investigating the world around them to understand how and why things work the way they do, and you give them a false teleological statement, given enough time and room, they will take apart that statement and say, this is incorrect, right? The moon was not created in order to tell us the time of the month, okay? We've made a calendar based on how the moon moves. It's the other way around, right? The sun does not shine in order to provide us with warmth, right? We've adapted to maximize the amount of sunshine for our biological needs, whether it's cultural or physical or biological adaptation. So given enough time, someone with the proper amount of training and experience and awareness, maybe it's formal, maybe it's informal, can realize, hey, it doesn't work that way. Yeah? Here's the thing though, it doesn't matter the educational level of attainment or the awareness or the experience, if you speed up those questions, if you make the environment stressful, everybody reverts back towards a teleological explanation for things. Right? You can see this in disasters. Why does this happen to me? Well, it's not happening to you. It is happening, and you're in it. Right? You know, the hurricane didn't come to hit you. You're at the place where the hurricane happens to be. And next year, maybe you'll be in a place where there's no hurricane, and somebody else is going to get hit by that hurricane, right? These are natural processes that happen repeatedly over millions and millions and millions of years. And statistically speaking, you know, a certain number of them are going to hit in a certain place at a certain strength over this stretch of time. And you happen to be there. It's not happening to you. It is happening, and you're in it. There's a difference. But under that stress, in that moment, we revert back to thinking of ourselves at the center of the universe, individually speaking. Because when we were infants, we were the center of the entire universe that we knew about. And there were these creatures that had infinite power over us. fundamentally, I think this is where religious thought comes from, right? And I think the tension between religious thought and scientific thought is actually the same kind of thing that you can see in a child who begins to realize that they're not the center of the universe. They're not the only person, that they didn't create the world and it doesn't exist for their benefit. About the age of 5, depending on the kid, depending on their environment. And when you see that happening in a kid, they get really upset. Like, what do you mean the world doesn't exist because I thought it up and it doesn't exist for my benefit? Are you kidding me? I hate this. Get me out of here. Right? I think this is part of what the so-called terrible twos are about. The realization that you're not the only one and it's not there for you. And frankly, as a child, you're like, fuck that. Me, mine, gimme. What the hell? And honestly, this is not to denigrate necessarily faith-based traditions or whatever. I think they're a very fundamental part of the way humans think. But I think they come from a place of infancy. They ask many of the same questions as the scientific, rational, logical side of our brains. Okay? Why are we here? Why is this happening? What's going on? Where does it come from? These are fundamentally basic questions that everybody wants to figure out how. The difference, in my opinion, is that if you can gain yourself a little bit of sort of intellectual leverage and try to step out from the center of the universe where everything is created for your benefit or is a punishment for your misbehavior, and realize that all of the things that we see going on in the world have happened for millions and millions of years prior to our existence as a species, and will continue to happen to some level or degree or another after we're long gone. And then you start to say, okay, why does it work that way? What's the driving underlying force, energy, material? And how can we access it?
How do you gain that leverage?
How do you gain that leverage? I mean, there's some easy, cheap answers to that question, right? Go to school, do your homework, read a book.
What's your perspective with when you get on the quantum level and you get strange, strange changes to reality based on observation, like
Schrodinger's cat and the collapse of the waveform.
Correct.
All of or sort of strange action at a distance.
Exactly.
So again, a little bit out of my wheelhouse.
Sure.
Okay, I'm not a quantum physicist,
Yep.
but I love that stuff.
Yeah.
I read about it as much as I can, and I try to wrap my head around it and fail, because basically, I like to put it this way, based on statements made by some pretty famous people like Richard Feynman or Marie Curie or the people who really delved into that stuff, is that any expert in quantum mechanics will tell you that nobody can explain quantum mechanics.
And yet they try.
And not only do they try, but they succeed well enough that we're able to do shit with it. Right?
Right.
I mean, they are now actually on the verge of being able to make so-called qubits, right? Quantum computers.
Which is going to be the end of crypto, by the way.
Right.
So
here's my take on the quantum stuff, and then to get back to how do we gain that leverage. The quantum stuff is, in my opinion, we are looking at an entire sub-universe or sub-system through very, very, very narrow lens that gives us a tiny, tiny glimpse. And so when we see one set of particle behaviors doing this thing over here, and we see another set of particle behaviors or waveform behaviors doing something slightly different and weird over there. What we have not yet been able to do is show that, in fact, we're looking at the same thing, but it's being expressed in a different way. And here's the example I like to use. It's from a book that I read. Imagine that there are 3 different people observing through a singly isolated camera lens.
Mhm.
And what they are observing, we know this, but they don't. What they are observing is a fish tank. Okay? And one is looking at the long side of the fish tank, one is looking at the short side of the fish tank, and one is looking at the top of the fish tank. And in the fish tank is a fish. Okay?
Right.
And one person sees the side of the fish, one person sees the front of the fish, and one person sees the top of the fish. They look totally different.
Right.
The fish moves, and each person reports some kind of movement, but the movement that they report is different, right? The person who's looking at the side of the fish sees this,
Mhm.
right? They see the wiggling of the flank of the fish. The other person sees the face of the fish moving back and forth, and the third person sees the top of the fish, and it looks like it's rippling. And they each report at the same instant this movement, but they report that the movement is totally different and that the shape of the thing is totally different. What they don't realize is that they're all looking at the same creature, which is why it seems like it's so simultaneous action at a distance,
Mhm.
right?
Right.
But what they're actually looking at are totally different faces of the same thing, but they don't know that. And I think that's where we're at with quantum and string theory and gravity waves and all
So
that
is
stuff.
that superposition?
Maybe that's what this superposition stuff is. You know, it's not actually superposition. It's not actually some sort of automatic change in the spin of some sort of quantum particle or whatever. Maybe it's just that the different observers are looking at different aspects and angles. And to lead back to the question of how to gain that leverage is whether you do it through books, whether you do it through school, whether you do it through some form of formal training, mathematics, chemistry, physics, philosophy, logic, whatever. Try as best you can to observe as objectively as possible. And try to not eliminate, because you never can. You can never eliminate your own personal bias. You are who you are. You grew up where you grew up. You experienced what you experienced. It shaped how you operate. It shaped the way your brain was structured. But to recognize that your experiences and what you see are happening out there. And yeah, your impressions and your feelings and your non-objective view is going to color or sort of tinge how you interpret what you see. But if you know that going in, then you can try as hard as you can to be objective. You can also do what I think is really important to do, which is really difficult to get across, which is to say, this is what I see. This is what I think is going on. This is why I think so, and I know I might be wrong. Right? We as a society have been experiencing that reality of science, the very human level of scientific behavior throughout this pandemic, right? When it started, wash your hands, wash the surfaces, you don't need a mask, right? And then that all changed, right? And the new thing was, don't worry so much about washing your hands and washing surfaces. Of course you should do it, but it's not like you need to spend, your company doesn't need to spend $100,000 installing, antiviral misters in every room. What you do need to do is spend a lot of money on air handling, and everybody needs to wear a mask, right? And then we learn more stuff. We're like, okay, these kinds of masks work really well, but they're expensive and stifling. These kind of masks work okay, and they're more comfortable, right? In this environment, we don't need to wear a mask as much. But in this environment, we should all be wearing a mask. Then it was, if you're vaccinated, you don't need a mask. And then it was, if you're vaccinated, you should probably wear a mask anyway if you're in close quarters. And what happens in society, you see this all over the place. People are like, why do they keep changing their story? Well, there's a really easy answer for that. We keep changing the story because we learn new stuff. And here's the thing, is if you have a story and it doesn't match with the new things that you've learned, you have a choice. You can either reject the new stuff that you've learned and stick to your story, or you can change your story based on new information. Right? Binary choice. I mean, you can get fancy and you can change parts of your story to match the new thing. You can do that too. Right? But at the fundamental extreme level, you can either reject the new information and keep your story, or you can accept the new information and change your story to match. One of those is scientific and rational, and the other is religious. Right? Mm-hmm. And my view, straight up, one of them will kill you, and the other one has a chance to not kill you. And we're not just talking about the virus or the pandemic in this situation. We're talking about all of it, right? If you see and learn and experience new information, right? Mm-hmm. And you do not change your behavior, bad things are likely to happen. You're driving on the freeway and you're going 80 miles an hour and you see a traffic jam up ahead of you. You've got new information about what speed is reasonable. And if you say, I reject that information, I'm going 80 miles an hour because I'm on the freeway, and when you're on the freeway you go 80 miles an hour, guess what's going to happen? You've got to change your story to match the new information, and you have to be flexible enough to keep doing it, because we don't ever have all the information, right? We don't ever know all things everywhere all the time. It's frustrating. It's confusing. It's disconcerting to think you know what's going on and realize that you don't. To think that someone with 30, 40, 50 years of expertise in the biomedical field of virology didn't know how this virus operated when that first came out and made a recommendation that turned out to not be that useful. Yeah. Right? And then it turns out there were a bunch of different reasons why don't wear a mask or don't need to wear a mask came out. One of them was they didn't think that this was a fully airborne virus.